Welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about reflex klystron. So reflex klystron is the microwave oscillator. So it is a type of vacuum tube used in electronics for generating and amplifying the microwave signal. So in the frequency range is 1 GHz to 40 GHz. So it operates based on the principle of velocity modulation and electron bunching. So here the name reflex comes from the fact that here the portion of energy is reflected back to the vacuum tube and used to modulate the electron beams. So which is useful for getting the higher efficiency and improved performance in oscillators. So it is called as the reflex klystron. So it is used in various applications like microwave ovens, radar systems, communication systems and particle accelerators. So generally it is in microwave oscillator. So these are the characteristics of klystron. Here the resonant cavity, it consists of a resonant cavity made up of two cylindrical cavities. So they are separated by small gap called the drift space. And the electron gun is used to provide the narrow high velocity electron beam, so directed towards the resonant cavity. So the electrons are focused by magnetic field and it is passed through a drift space. And next is the bunching process. Here the electron pass through drift space. They are affected by the electric field produced by the resonant cavity. So this causes the electrons to bunch together, forming the group of bunches. So there are two purposes. One is amplification and another one is oscillation. So when bunches of electron pass through the cavity and causing the field to be amplified. So the amplified field then interacts with the next bunch of electrons, resulting in further amplification. Next is oscillation. So the interaction between the electron beam and the resonant cavity can cause to oscillate at a frequency. This frequency is determined by the dimensions of the cavity used in the resonator. So this produces the microwave signal. It is used for various applications such as radar and communication systems. So let's see the construction and working principle of reflex klystron. So here we can see the resonant cavity. So here the electron beams are emitted from the cathode and travel through the drift space, and the interaction of electron beam with the cavity to generate and amplify the microwave signals. Here the repeller is used for reflecting the electron beams. So electron beam formation. The electron beam is produced by an electron gun and directed towards the resonant cavity. And next is the bunching of electrons. And repeller distance and repeller voltage can be adjusted to receive all the electrons at the same time on the positive peak of the cavity RF cycle. So the velocity modulated electrons are bunched together and lost their kinetic energy when they encounter the positive peak of the cavity RF field. So when the power delivered by the electrons is equal to the power loss in the cavity, microwave oscillation is started. So amplification and oscillation. The interaction between the electron beam and the resonant cavity can cause the cavity to oscillate at a frequency determined by the cavity dimension. So this produces the microwave signal. And reflected energy. A portion of energy from the output signal is reflected back to the tube and it used to modulate the electron beam. So this results in the higher efficiency. So this is the example for a resonant cavity where interaction takes place. When the bunches of electron pass through the cavity, they interact with the electric field. So it causes the electrons to gain energy, which results in the increase in the velocity of electrons. And advantages are it provides high frequency stability, which makes them useful in application that require stable signals, and high power output. So it requires high power output such as radar and communication systems, and compact size. So it can be reflex klystrons can be relatively small in size compared to other microwave tubes, and low noise. So because of the low noise levels, they can be used in applications that require high signal to noise ratio, such as communication systems, and also long lifespan. And there are some disadvantages: high voltage requirement. So to operate, it requires a high voltage power supply and limited frequency range and limited power control. And so they are sensitive to temperature changes and also complexity of microwave tubes. And applications of Klystron: radar receivers, local oscillator in microwave receivers, and portable microwave links, pump oscillators in parametric amplifier. And performance characteristics are: the frequency range from 2 to 200 GHz, power range from 10 milliwatts to 2.5 watts, and efficiency is 22.78 in theoretical, and practical efficiency is 10 to 20%. Let's take the assessment. The Klystron tube used in Klystron amplifier belongs to linear beam, and which is a single cavity Klystron tube that operates as an oscillator by using a reflector electrode after the cavity. It is the reflex Klystron. Thank you for listening this lecture.